Hello and welcome. In this video, we're going to be discussing how to solve a time rate work problem. So let's begin with this one. There are two machines that produce 6,600 cans. The newer machine can produce 6,600 cans in 220 minutes. It takes the older machine 330 minutes to produce that many cans. If the two machines work together, how long will it take them to produce 6,600 cans? So I want you to notice there are different types of units referenced in this problem. We've got 6,600 cans, we've got 220 minutes, and then there doesn't really seem to be a link between the two. So what would be that link unit? Well, to kind of see that, let's start with a pretend situation. So suppose that I knew that my machine could crank out 10 cans per minute. And let's say I gave that machine 5 minutes to do work. How many cans could I produce in that 5 minutes? Well, notice that for each minute, my machine is producing 10 cans. So if I gave the machine 5 minutes, the total number of cans I could produce would just be 10 times 5, which would be 50 cans. So what you'll notice is that I've got my time here, my cans here, but really what I'm missing in the problem is a rate. I'm missing the cans per minute. But this is the formula we're going to use. So I'm going to write that formula down. So cans per minute times the number of minutes is going to give us the number of cans. So you'll also notice that in this problem they reference two machines. So I'm going to label down the side our machines. So we've got the newer machine and we've got the older machine. And then I'm also going to put a third row for combined. So what do we know from the problem? Well, we know that the newer machine, it says, can produce 6,600 cans in 220 minutes. So when I'm filling in the items in my table, and I forgot to draw in the lines here, I'm just going to draw on a table so that the cells are more clearly defined. So I know the newer machine can produce 6,600 cans and in 220 minutes is what it said. The older machine, says, can produce 6,600 cans because it says it can produce that many cans, so they're referencing the 6,600 number, in 330 minutes. So we could put those numbers in our table as well. So it takes the older machine 330 minutes to produce that 6,600 cans. And then what we're interested in this problem, it says, is if the two machines work together, how long will it take them to produce 6,600 cans? So what we're interested in is combined, how long, if these two machines work together, would it take them to produce 6,600 cans? So we're really looking for the amount of time it would take for the two machines together to do this. So what I'd love to figure out is how fast the newer machine is working per minute, how many cans it's pumping out, and how many cans the older machine is pumping out per minute. Because then I'll know, or I can figure out, their combined work rate. So since I don't know how fast the newer machine is working, I'm going to call that X. The older machine, I have no idea how fast that one's working, I'm going to call that Y. And then their combined rate would be whatever X is plus whatever Y is. So we can produce several equations from the rows of our table. The first equation that we can produce is, well, when we look at the first row, what I know is if I take the newer machine's work rate times the number of minutes that I give it, that should equal 6,600. So in other words, X times 220 has to equal 6,600. Likewise, in the second row, 330 times Y equals 6,600 as well. From the bottom row, we've got X plus Y times t equals 6,600. So what I'd like to do is start by figuring out what x and y are from these two equations. Then I can plug those in and then solve for t. Okay, so if I want to figure out what x is from the first equation, I'm just going to divide both sides by 220. If we do that, we get x equals 30. In the bottom equation, or excuse me, in the next equation, divide both sides by 330. And that gives us y equals 20. So now when I'm solving this bottom equation, I'm just going to plug in my x value and my y value, and then we're going to solve it for t. So I've just given myself a little extra room, so I'm going to take my x, plug it in, take my y, plug it in. That gives me 30 plus 20 times t equals 6,600. 30 plus 20 is 50 times t equals 6,600. Divide both sides by 50, and that gives me t equals 132. So if both machines are working together, it would take them 132 minutes to finish the job. So that answer does seem reasonable because we know that alone the newer machine can do the full job in 220 minutes and the older machine can do the full job in 330. So we would expect if they're working together, it would take less time than either one of them working alone. Okay, here's another one for you to try. Pause the video and then restart it after you've given it a shot. Okay, so if we begin with this problem, again, notice that we have different types of units. We've got gallons, we've got minutes, and then we have to find a way to link those two kinds of units together. So let's again begin with a pretend situation. So suppose that I've got a pipe that can drain 5 gallons of water per minute. And then I give that pipe 10 minutes. The question is, how many gallons of water would be drained in those 10 minutes? Well, for every minute, 5 gallons of water are drained. So if I want to know how much is drained in 10 minutes, I would just multiply those numbers together, and that would give me 50 gallons would be drained. So that gives us our equation that we're going to use. So it's going to be gallons of water per minute times the number of minutes equals the number of gallons drained. And then you'll notice in this problem we again have two different types of pipes. So I'm going to label our information down the side. We've got the first pipe and the second pipe. And then I'm going to have a third row for combined information. And then I'm just going to draw my table. Okay, so what do we know? Well, it says that the swimming pool holds 540,000 gallons of water. It says the pool has 2 drainage pipes. It says the first pipe alone can empty the pool in 225 minutes. The second pipe can empty it in 150 minutes. So what I know is that the first one takes 225 minutes. The second one was 150 minutes. And what do they mean when they say drain the pool? Well, they mean drain all the water. So that means 540,000 gallons. So after 225 minutes, the first pipe would drain all 540,000 gallons. Likewise, the second pipe in 150 minutes would drain all 540,000 gallons. So what we're looking for, if we look at the question, how long does it take to empty the pool if both pipes are working together? So that really speaks about the combined row. So we want to know how long it's going to take both pipes together to drain all 540,000 gallons. And since we don't know how much time that is, we're going to call that T. We don't know how fast The first pipe is draining water, so we'll call that X. Second pipe we'll call Y. That means their combined rate would be X plus Y. And this is going to be similar to the first one. So when we look at the first row, we've got an equation there. The number of gallons per minute times the number of minutes should equal the number of gallons drained. So that first row basically says 225x equals 540,000 gallons. Likewise, the second row says 150 times y equals 540,000 gallons. And then the third row would be x plus y times t equals 540,000 gallons. So if we solve the first one for x, divide both sides by 225, and that gives us 2,400 for x. Second one, divide both sides by 150, and that gives us 3,600 for y. Then we can take our x and our y and plug those in down here. So that gives us 2,400 plus 3,600 times t equals 540,000. 2,400 and 3,600 is 6,000, so that's 6,000 t equals 540,000. Divide both sides by 6,000. And that gives us t equals 90, which is exactly what we were looking for. So it would take 90 minutes if both pipes were working together to drain the pool. And again, the answer seems reasonable because it's less time than either one would take to drain the pool individually.